In this video, we're going to start off with a definition of what is called a parallel projection. So given three lines, and you can see three lines here. Here's line L, line M, and then we have this line N over here. The function f that maps line L into line M, which that means any point on L will get mapped to a point on M, is called a parallel projection if for each point x on the line L, for every point on here, f of x is going to give us a point x prime, where x prime is on the line M, and the line x prime is parallel to this one. So we're just going to draw a picture for this definition. It's going to be very simple. From A is going to get mapped to A prime on M. And how are we going to find A prime on this line? We're going to take this line in and make it go through A in our minds. Make sure it's parallel. So I made this look like a horizontal line, so I'm going to go straight to there. That would be my A prime. Similarly for B. From B, draw a line parallel to N, and that will give us B prime. From C, draw a line parallel to N, and that gives us C prime. So you can see that every single point on L will get mapped to a line on M. And we know how to do it. Just connect the point with a line parallel to N and see where it intersects on the line M. Now a theorem that we'll call parallel projection. If F, mapping from one line to another line, is a parallel projection, then the following will hold true. And we'll keep this diagram in view here. The function f is 1-to-1. Okay, it's a 1-to-1 correspondence. That is, if you take 2 points on the line L, I call them x and y, but we could call them A and B, two different lines, then they're going to get mapped to two different lines over here. You could never have B map to A prime, because in order to do that, you'd be drawing a line that's not parallel to N, right? So all the projections are going to be from this line, draw a line parallel to N to get to the other line, to get to the other point. Okay, so it's 1-to-1. If P, Q, and R are 3 points on a line, and we'll say that Q is in between P and R. Well, that tells us that on the projected line, where we're going to have a P prime, Q prime, and R prime, they're going to be in the same order as this. We're going to have P prime, or maybe I'll say Q prime is in between P prime and R prime on the line, let's see, what did I call? Over here I called it on the line M, but here I called it on the line L prime, so I'll call it L prime there. Okay, so that means that between this is an invariant property. If Q is in between P and R, when you map them using the function f, their output points, Q prime will be between P prime and R prime. Just like we saw up here, B is in between A and C. Well, that means that B prime will be in between A prime and C prime. Okay, last piece of this video. It's a lemma called ratio parallel. Given a triangle. So I'll just label A, B, C. Doesn't matter how you label it. Okay, we've got that triangle, ABC, and points E. So E has to be on segment AB. I'll put it there. It doesn't say it needs to be the midpoint, so just put it anywhere you want on that side. And F is an element of AC. Now let's draw it in such a way that the length of AE divided by the length of AB gives us a ratio. And I would say the ratio in this case, I would say this is about 1/3. E is about 1/3 of the distance from A to B. So I would say that AE is about 1/3 of AB. So now let's make one over here where it's about 1/3. That's about 1/3 of that whole distance. Okay? So we have AE over AB is equal to AF over AC. So let's just repeat that again. Let's say we're talking about a ratio of 1/3. If I went 1/3 of the way from A to B, that would give me E. If I went 1/3 of the way from A to C, it would give me F. If that's the case, then this line, or the line segment, if I'll call it a line, EF, that line, is parallel to the base, BC. Simple lemma that's a little bit like the median, the theorem that had to do with the median of a triangle, because if we went halfway down, if we took the two midpoints, we knew that that length was 1/2 of BC. Well, if we come down 1/3 of the way in both directions, then that length is 1/3 of the base. If we go down 3/4 and 3/4, connect that line segment, which is parallel to BC, it would be 3/4 of the length of BC.